So let's take just a few minutes to briefly recap the procedures that we hopefully learned in ELPA 7810 Educational Statistics, the main ones that our case studies are based on. So let me just take just a while to kind of go over those very quickly. And so let's just kind of start listing them. The first thing that we learned, one of the first things we made SPSS calculate was a correlation. And we recall that a correlation is a number that's designated by R. If I can figure out how to do this, you would probably rather me type than try to write, although my baby stuck writing. The value is R, and R is always between -1 and +1. And R tells us two things. It tells us direction, and it tells us strength. So the further away from 0 R is, the value of R may be a 0.23 or maybe -0.75. The further away from 0 R is, the stronger the correlation. And you'll remember we plotted these things in scattergrams, things like that, and we saw that stronger correlations had the dots clustered more closely together around what would be a straight line. Anybody remember what we called that line? The line of regression. Hence the term regression for our simple and multiple regression that you see on the syllabus as one of the first topics. So that's what a correlation is. It just tells you strength and direction. Is a high score in one set, does that correspond to a high score in the other set? If so, that's a positive correlation. Does a high score in one set correspond to a low score in another set? That would correspond, or that would be indicative of a negative correlation. Also, just to throw another example, if a low score in one goes with a low score in the other, that's also a positive correlation because it means they go the same way. High with high, low with low, that's the same. But if high goes with low, that's the opposite, which would be a negative correlation. So a correlation is one of the first things that we got SPSS to calculate. After we got it to calculate descriptive statistics like means and standard deviations. We spent considerable time on t-tests. The reason we spent considerable time on them because there are 3 of them. A single sample t-test, or sometimes you see that as a one sample t-test, allows us to take a set of numbers. Again, remember that we call a set of numbers a distribution. It allows us to compare the mean for that distribution with a set number. First example we used was, let's say we've got a bunch of cars and we know what their individual miles per gallon are rated at, and we wanted to see if they're significantly different than, I think we used the 45 miles per gallon. Are they getting 40? The question was, is their average mile per gallon significantly different than the 45 that we're looking to see? So we've got sort of a benchmark number, or a test value, which is what SPSS asked for. So a single sample t-test compares the mean of a set of numbers with a particular number. An independent t-test compares 2 groups together, or the means of 2 groups with each other. Is the mean from this group significantly different from the mean of that group? And it's independent because if you've got a number in one set, that number doesn't have anything to do with the number in the other set. They're just all individual. And likewise, if you're a member of one group, you're not a member of the other group. And again, as always, I'm enjoying watching everybody writing like crazy, like you've never heard this stuff before. I know it's been like almost a semester for some of us. More for some of us. Okay, so in independent, the groups are independent. 2 groups. Sometimes a piece of data in one group is associated with a piece of data in another group, or they're paired together. Therefore, we may have a paired t-test. Common example would be your pre-test scores compared with your post-test scores, because every individual produces two pieces of data, a pre-test and a post-test. So a particular pre-test goes with a particular post-test because they're both produced by the same person. So paired together, we talked about a lot of examples in terms of the way data might be paired, but that's probably the most straightforward example. So let's go back to this idea of an independent t-test for a second and play a little what if. A typical example of an independent t-test might be something like, do the test scores from this class differ significantly from the test scores from another class, two classes? It's a t-test because the t-test has, it compares two things, in this case two groups. But what if I have a third class in there? Ms. Smith's class, Mrs. Jones' class, Mrs. Johnson's class. To be stereotypical, I guess, classroom test scores, because that's something we're all familiar with. So, all of a sudden, I have sort of they're independent because if you're in one class, you're not in the other class, but I've got three different groups. So in that case, I have to run an Anova, or an analysis of variance. The lazy statisticians call it an Anova, analysis of variance, to see if there's a significant difference between any two of the groups. If I've got three groups, I can come up with three different pairs. If I had a fourth group, I can come up with even more different pairs. So that's why you have in SPSS, you'll remember that pairwise comparison part of the output. And keep in mind, the Anova does two things. In my illustration, it's kind of like I've said, if you go up to someone and you say, do you know what time it is? The answer is either yes or no. If the answer is no, the conversation's over, unless you talk about something else. But if you say, do you know what time it is? And the person says yes, well, there's a follow-up question. Okay, well, then what time is it? You don't just say yes and walk away unless you're like a smart aleck like I am. I've actually sort of done that. But do you know what time it is? Yeah. Oh, what time is it? And then that second question hopefully gets answered. So 2 steps to an Anova, or up to 2 steps. The first step says it answers the question: is there a significant difference anywhere between any pair, any two groups? And if the answer is no, that's it, you're done. But if the answer is yes, the follow-up test, the post-hoc test, remember we typically use a 2-key test, but we remember that SPSS had half a dozen or so to choose from. If the answer is yes, there is a significant difference at least somewhere, then the post-hoc follow-up tells you between which pairs that is. It may just be between one pair, or one group and another, just one pair. Or it may be between all the pairs. You don't know. So you got to look at them 2 at a time. And the last test we spent a fair amount of time on was the chi-square test. And as we introduced chi-square, one of the things we said about it is that chi-square kind of brings us full circle, because the very first class session we talked about different types and different levels of data. And the lowest level of data is nominal, which simply is just names, categories, labels. And chi-square can deal with nominal data, like you're in this group or that group, and there's no quantitative difference necessarily. It's just, you've got the blue group and the brown group or whatever. And our example was the Titanic problem. And the 2 variables that Titanic problem used, and this is an example of a 2-way Anova, or crosstabs, as is put sometimes. Okay, where was your lodging? Either here or there. Did you survive? Either yes or no. Both those variables are nominal variables. Now, you would argue that there's a hierarchical relationship between survival, right? And that yes, it's generally better to survive than not. But it's just a yes-no question the way we treat it. Again, because we don't put values on things unless they're numerical in nature, but we all know that, yeah, it's better to survive, but the yes, no is still a nominal, they're still nominal categories. So in about 10 minutes or less, that was 7810. See how much time you could have saved yourself if you just listened to this one little mini lecture? Questions or comments? Anything you want me to elaborate on a little more? And we'll see some specific examples in the case studies. So far, so good? Nothing new, but you're still writing like crazy.